Well, today we're going to talk about one of the great instruments of science, the Voyager spacecraft. They are on their way, and Neil deGrasse Tyson cries out, confirming the most confusing and fearful discovery made by the Voyager in the past decade. A discovery that scientists were in no way prepared for. Ever since the Voyager craft sent back this disturbing data from space, the scientific community has been unable to sleep, and everyone is walking under a tense atmosphere. Researchers, scientists, and engineers have been scrambled from their stations to combat these mysterious objects that Voyager 1 just spotted. We don't know where these strange objects are coming from or where they are headed, but what we do know is that we have seen nothing like them before. What are these mysterious objects that were recently discovered by Voyager 1? Join us today as we dissect these answers with Neil deGrasse Tyson. Voyager 1 has detected 500 unknown objects passing by in space. For almost 5 decades now, Voyager 1 has been sailing through the highways of space, exploring the deep realms that ground-based telescopes have been excluded from seeing and uncovering. A product of genius minds that flow in abundance at the Johns Hopkins Jet Propulsion Laboratory, Voyager 1 has been the golden messenger to the uncharted territory of intergalactic space. This engineering masterpiece has opened our eyes to the mind-blowing wonders that exist in our cosmos. In a recent development, Neil deGrasse Tyson has confirmed that Voyager has detected 500 unknown objects gliding peacefully in space. This news came as a shock to the scientific community, rattling scientists as everyone began poring over the data obtained by Voyager 1. Something strange was brewing on the horizon, and it was difficult to solve this bubbling puzzle that had dumbfounded even the best of scientists. Ever since Neil deGrasse Tyson confirmed this discovery, different interpretations have been flying in the air in an attempt to sketch a vivid picture that explains this mystery. If it had been another spacecraft that transmitted the type of bewildering data recently transmitted from space, scientists might have doubted the validity of the data. However, it is Voyager 1 we are talking about here, the space probe that has been cruising through the steamy paths of space for almost 50 years now and has exceeded our expectations. Like a patient who beat cancer, Voyager 1 has exceeded scientists' projected lifespan of 3 years to spend over 45 years in space, uncovering history-making discoveries. Simultaneously, the most intriguing part about this iconic tale is that Voyager is writing the success story from a very far distance from the Earth. The last time scientists checked, they saw that the space probe was 14.5 billion miles away from our planet, speeding away in space with no sign that it would reduce its pace anytime soon. Researchers say that the space probe has been traveling at a rate 3.6 times the distance between the Earth and the Sun per year. This is one pill that scientists have found a bit hard to swallow because naturally, one would have expected the space probe's speed to have declined greatly given the longevity of its journey in space. On closer look, it seems Voyager 1 is destined to be the exception when it comes to this narrative, and it has shown evidence of this once more with its latest findings. It was just like every other day for scientists when Voyager 1 slammed exciting news on their faces, one that would stick in their memories for ages. Voyager 1 had stumbled on some mysterious objects passing by in space. This discovery was unplanned, which explains the initial confusion of astronomers when they glanced over data showing that about 500 unknown objects had appeared from nowhere. One moment we didn't know about the existence of these objects, and the next moment we had scientists cracking their brains in search of an answer to this puzzle that nature had landed on their laps. Scientists were in a fix, and the blame could be traced to only one guilty party, Voyager 1. Ironically, scientists also knew that the solution to unraveling this mystery rested on the heavy shoulders of the space probe. Initially, when news of this discovery broke out, some scientists considered the possibility that it could have been a mistake. They thought that the age of Voyager might first be catching up with it, and hence it may be transmitting wrong data back to us. If we decide to walk on this unfolding path, it seems like a plausible explanation given the fact that Voyager 1 was launched as far back as 1977. That's almost 5 decades of active service on behalf of humanity. One can only expect that the spacecraft's computers would have grown weary and started to malfunction, shrinking in their responsibilities and sending back poor quality information to the ground team. As alluring as this narrative sounds, scientists have advised that we shouldn't tread there because it would be a slap on the selfless spirit of Voyager. Despite the harshness and unpredictable environment of space, Voyager 1 has consistently churned out eye-opening data about our cosmos. Contrary to the hurried assumptions of skeptics, the space probe has maintained its long life thanks to its dual redundant computer systems. Like its twin, Voyager 2, Voyager 1 came equipped with two sets of command subsystems: Flight Data Systems, FDS, and Altitude and Articulation Control System, ACCS. This has been the secret power behind the spacecraft's unbroken fighting spirit when it comes to chartering through space and uncovering discoveries. The redundancy paved the way for seamless transitions between systems and the ability to activate dormant computer components, thereby preserving their lifespan. When designing Voyager 1, the engineers back on Earth came up with a plan to help the space probe maximize efficiency. This required that the probe's instruments rely on hardwired logic. They were taking no chances when it came to this area since they were handicapped due to time constraints and limitations in power budgets. The electrical engineers decided the instruments would have to be developed using simplified systems that depended on hardwired logic. Thus, Voyager's computer systems comprised 6 onboard computers organized as a distributed system with 3 dual redundant pairs. Having overcome this hurdle, scientists had to face the next tall brick wall in their way: maintaining the systems. This intimidating height was surmounted by coming up with an ongoing power management plan. Power management entailed sustaining the operational capabilities of Voyager's computer systems, and this is an arduous task to deal with given the limited power resources available on board the space probe. It was a case of sending a hunter into the deep jungle to hunt for wild animals with only a set of knives. Nevertheless, scientists found a way around this problem by devising several measures to conserve and optimize power usage aboard Voyager. A good example of these power management measures is the selective powering down of non-essential systems. Engineers were forced into making this hard decision. Hence, they employed a systemic approach to identify and deactivate components or subsystems that are not crucial for the spacecraft's primary mission objectives. We see evidence of this when we take a quick look at heaters associated with certain instruments that had to be switched off. These heaters were originally designed to maintain the instruments at specific temperatures so they would operate or perform optimally. However, the story had to be rewritten by activating them because it greatly reduced power consumption on board Voyager. This reduction in the spacecraft's power usage comes with a ripple effect, an extension of Voyager's lifespan. It's a win-win situation for everybody. Moreover, we should bear in mind that this decision to power down non-essential systems is not taken lightly. It is a premeditated activity that requires careful evaluation of the trade-offs between power conservation and the scientific objectives of the spacecraft. Whenever such a decision was taken, all hands had to be on deck. Engineers and scientists had to sit together and evaluate the impact of deactivating specific systems on the quality and availability of scientific data. Emotions weren't at play here. It was strictly business based on the facts at hand. The team was driven by the desire to maximize power efficiency while maintaining the essential functions of the spacecraft so it could continue to gather necessary information about our universe undisturbed. Engineers and scientists alike didn't want anything to hinder Voyager's path when it came to uncovering the deep secrets locked away in hidden realms of space. Secrets that the universe has been keeping away from us for centuries now. However, selective power reduction isn't the only way that NASA engineers are keeping the Voyager afloat and operating optimally in space. They had another ace up their sleeves, which they had to place on the table for the benefit of the spacecraft. Alongside scientists, the engineers had to come up with power management strategies that are adapted to the ever-changing conditions of the spacecraft's environment. For instance, as Voyager 1 travels farther away from the Sun, the available solar energy takes a nosedive. This is a problem, but the engineers came prepared. They compensated for this growing threat by ensuring that the spacecraft adjusted its power use accordingly. This adaptive approach is a masterstroke on the part of NASA engineers and scientists, because it ensures that the available power resources are efficiently allocated to support the probe's key operations and data transfer back to Earth. Interestingly, the good news doesn't end here. There have been ongoing technical advancements and upgrades in power management which have made room for engineers to refine and optimize the power systems of the spacecraft over the years. A close look at these enhancements would reveal that they involve more efficient power distribution, improving battery charging methods, and advancements in power regulation and control. The implementation of well-thought-out and planned power management strategies has opened an exciting door for engineers. It has made it possible for engineers to extend the operational lifespan of Voyager 1 alongside its twin, Voyager 2. This is a big win for the scientific community and the world at large. The careful allocation and management of power resources have equipped Voyager 1 with the requisite strength needed to keep exploring the depths of space unhinged without fear of failure. The spacecraft has experienced an intriguing scientific journey, one where its critical systems remain functional despite its old age. Hence, it can transmit valuable data and pictures back to us. The grand story of Voyager 1 and its stunning discoveries, including the sighting of 500 mysterious objects in space, is a testimony to the indomitable spirit of human curiosity and scientific excellence. Voyager 1's findings have set the stage for the next chapter in our understanding of space, and the world eagerly awaits further revelations. The space probe has paved the way for many discoveries and has showcased how remarkable human ingenuity can be, even against the backdrop of the infinite cosmos. The discovery of 500 unknown objects by Voyager 1 has sent ripples through the scientific community, igniting debates and discussions about their nature and origins. These objects, previously uncharted and unexpected, have not only stirred curiosity, but have also emphasized the limitations of our current astronomical models. As Voyager 1 ventures further into the interstellar medium, the observations may challenge our understanding of cosmic phenomena and highlight the need for advanced theoretical frameworks. One of the key questions that scientists are grappling with is the composition of these mysterious objects. Are they cosmic dust particles, fragments of ancient celestial bodies, or something entirely unprecedented? Traditional models of interstellar matter suggest that space is relatively empty, with particles spread thinly across vast distances. The sudden appearance of numerous objects challenges this assumption and suggests that our models may be incomplete. Researchers will need to revise their theories to accommodate these findings, potentially leading to groundbreaking developments in our understanding of the cosmos. Additionally, the nature of these objects could have implications for the study of cosmic evolution. For instance, if these objects are remnants of long-dormant or ancient celestial events, they could offer insights into the history of the universe. Understanding their origins might reveal information about the formation of stars, galaxies, and other cosmic structures. This could also help clarify the processes that shaped the interstellar medium and contributed to the current distribution of matter in the galaxy. Voyager 1's detection of these objects also raises questions about the potential for future space missions. As spacecraft venture farther from Earth, they encounter new and unexpected phenomena. The discovery highlights the importance of continued exploration and observation to gather more comprehensive data about the environment beyond our solar system. Future missions might be designed to investigate similar regions of space, using advanced sensors and technologies to capture detailed information about unknown objects and their interactions with other cosmic elements. Moreover, this discovery underscores the importance of international collaboration in space exploration. The scale of space missions and the complexity of interpreting data from distant probes require a collective effort from scientists and engineers around the world. The global nature of space research means that expertise and resources can be pooled to address the challenges posed by these new findings. Collaborative efforts can lead to more robust analyses and innovative solutions, ultimately enhancing our collective understanding of the universe. The technical challenges faced by Voyager 1 in its long journey through space are a testament to the ingenuity of the engineers and scientists behind the mission. The spacecraft's ability to operate effectively despite its age and the harsh conditions of space is a remarkable achievement. This success story provides valuable lessons for the design and operation of future space missions. The resilience of Voyager 1 emphasizes the importance of redundancy, robust engineering, and thoughtful power management in the development of long-term space exploration technologies. As scientists continue to analyze the data from Voyager 1, they are also exploring new methods to enhance data collection and analysis. Advances in computational techniques, such as machine learning and artificial intelligence, could play a crucial role in interpreting the vast amounts of data generated by space missions. These technologies can help identify patterns and anomalies in the data, providing deeper insights into the nature of the objects detected by Voyager 1 and potentially uncovering new aspects of space phenomena. In addition to scientific implications, the discovery of these objects has captured the imagination of the public and inspired a renewed interest in space exploration. The idea that there are unknown entities drifting through the cosmos stimulates curiosity and wonder, encouraging people to learn more about the universe and our place within it. This fascination with space can drive educational initiatives and inspire the next generation of scientists and engineers to pursue careers in space science and technology. The Voyager missions, including Voyager 1, have been instrumental in expanding our knowledge of the solar system and beyond. The spacecraft have provided invaluable data on planetary systems, interstellar space, and the broader cosmos. Their legacy continues to influence space exploration and scientific research, setting the stage for future missions and discoveries. The detection of these mysterious objects is yet another chapter in the ongoing saga of space exploration, demonstrating the enduring quest for knowledge and the excitement of uncovering the unknown. In summary, Voyager 1's recent discovery of 500 unknown objects represents a significant milestone in space exploration. The findings challenge existing models, offer insights into cosmic evolution, and highlight the importance of continued exploration and international collaboration. The technical achievements of Voyager 1 and the potential for future advancements in data analysis and mission design underscore the dynamic nature of space research. As we delve deeper into the mysteries of the universe, the legacy of Voyager 1 will continue to inspire and inform our quest for understanding the cosmos.